I'm sharing the Microsoft Word of the procedure, and then we'll go through the this is a Microsoft Word. The experiment today is number 4 and is about chemical reaction, and you can see it in the tab of it says chemical reaction. We'll know today or learn about five types of chemical reactions. So the first one here called single replacement, or sometimes called just displacement. In this sense, you will have today opportunity to look at the experiment zinc plus copper sulfate. Okay, the zinc with copper sulfate will give you, zinc will take over the copper, leaving the copper orphan here by itself. So you get zinc sulfate plus copper. So if you look at this here, this is copper sulfate is pentahydrate, of course. This is blue solution. This zinc is a silver grayish metal, and come and take over copper out of its salt. So you get zinc sulfate, which is colorless. This is a colorless solution. So the reaction is slow, but it's very effective. It takes about 30 minutes for this experiment. So what we have to do in this experiment here, I take this one here, show you how what you're expecting to do. So you will have 2 test tubes. So you have 2 test tubes here. This is number 1. This is number 2. So what you will do here, one will be as a reference. Number 1 will be your reference. So this is a reference one. It will have about 20 drops, which is 1 ml. Remember we said 1 ml is 20 drops of copper sulfate of the blue solution. Blue solution of copper sulfate. So here is copper sulfate. It's pentahydrate. It's a blue solution. So here you will add the same thing here, the 20 drops. The 20 drops of copper sulfate, pentahydrate, of course, the blue one. However, what will happen here in this, you will add small 2 pieces of zinc. So you'll add to this test tube number 2, you'll add 2 pieces, 2 small pieces here. Well, I did not want to take it, but just back again. This is test tube number 2. I apologize. So this is test tube number 2. It has a copper sulfate, and it has about 2 pieces, small pieces of zinc. And then you leave it there, test tube number 1 as your reference. Number 1, just keep it there. So you'll keep all those test tubes in a rack. There is a plastic rack where we call it test tube wooden rack or holder. Okay, so it has a couple holes here. So something like this. It has in between holes here, and then you just put your test tube You put your test tube here. Let me change the color so you can see it much better. So your test tube will come here. This will be held. Test tube number 1. It has 20 drops of copper sulfate. Test tube number 2. It has zinc plus 20 drops of your copper sulfate. After 30 minutes, and that's the longest type of reaction here, very slow, but it's efficient. You will see the blue color here. The blue color is fainting. The blue color faints out, faints. Okay, so now I want to show you just a little bit of YouTube. I hope I'll stop sharing, then I will go to share with you the just a little bit to show you how the reaction is doing. So let me share. First of all, back and look at the reaction here. Let's look at the reaction first. The zinc is called, this is single displacement, and the zinc will come in the procedure here. The zinc will come and take over the sulfate. Here it is. This is, I'm highlighting this one here. This is the first type of the reaction here you have. And this is the procedure. So highlighting this one yellow. And the whole thing here maybe red, so you can. So this is the first type of reaction, single displacement or replacement. Now, if I take this one link here and then copy it here, copy this link, and I'm stop sharing, and I'm sharing the YouTube here. Sharing the YouTube, and just write the link in the YouTube, paste it and search it. And you can see how the copper is reacting with this. So I hope the sound is there.
What are the greatest joys of your day?
Here they use beakers. We can use what? Test tube. 20 drops. Not that much. That's too much waste of facility. 20 drops. Control me, our reference. Not go through this, but at least you get the idea, and we can just. That's the end of the here. See here, after a while, after 30 minutes, the color is painting, the blue color is painting, and then you get a black cover on the zinc, on the piece of this. I mean, this is the zinc here. Okay, so going back to our sharing Microsoft Word, I'll be back and forth because the WebEx is not allowing us to, unless you get out of share and come back, reshare, and it's not to one spot at the same time. So that's the first type of reaction we have. Let's go look at the second type of reaction. If I have a single replacement or displacement, then I can have what? A double, correct? So I can have a double. So let me show you here an example here. We have a single, then we'll have a double. So we have a double displacement. In this double displacement, we'll have calcium chloride aqueous. This is colorless solution, colorless. And you'll add to it sodium phosphate, BO4, correct? So the BO4 is phosphate here, sodium phosphate. What will happen here, you get calcium phosphate, and this is a white solid, white precipitate, PPT. PPT is precipitate or solid, okay? So what's happened is calcium is, maybe you get another color here. Calcium here, guys, take over the phosphate, okay? And then you have the sodium here, take over the chloride. So they are swapping their partners, okay? Call this one swapping their partners, meaning the cation calcium will take over the anion of sodium. And then sodium cation will take over calcium anion. So they are swapping their cation versus anion. Yes. White PPT means precipitate. Let me show you how to pronounce or how to type this. Precipitate is the word here. I hope it will work. Precipitate. Those are eyes here. So those are eyes. Precipitate means solid. Okay, so solid. So this is the second type of reaction. So what you will do in this, do you have any question about this? Any question, please? What you will do here is the same. You will have 20 drops. We will not waste our chemicals. We'll not do the like they did in a beaker, because they are doing a real professional demo, a lot of chemicals. No, we'll do just small tiny thing. Let me take this one here out, and okay, so let me take this one out, and then I will say here we have 2 test tubes, 1, 2. This is number 1, has our calcium chloride solution, correct? And number 2 has our sodium phosphate solution. Both solutions are colorless. This is SOL. Now you take number 1. How many? 20 drops. And remember, 20 drops in our, what we said, is about 1 ml. Okay, and here you take of this here, 20 drops of calcium chloride and 20 drops of then what you will do here, you will transfer, take that. It does not really matter which is which, but usually you take the calcium because calcium is causing the precipitate. So when I see it, dump all these 20 drops inside the other 20 drops, and still you will see a very nice, and it's not really hard solid, but a milky solid, turbid. There is turbidity there, but if you let it dry, it will come out as calcium phosphate. What will be the calcium phosphate? What we call it? Come on, what calcium phosphate is used in the real life? This is a very important component of our what? Yeah, calcium phosphate. That's a very important. When you speak about bones, there's some other stuff, tissue, some other stuff inside the bones, but this is the major one. This is the major. There is no bone without calcium phosphate. So this is we call double displacement. This reaction is double displacement or replacement. Okay. So any question, please? Any question? I'll show you just very few seconds or less than 1 minute video because I put for you the whole thing. Let me share with you the take this one out, and I'm doing stop sharing here, and I'm sharing the first of all I have to go back, share this Microsoft Word, and see where the double displacement or replacement reaction is, because I put that for you. I think that's the best way for students to come and look at some of the videos there. So this is the reaction here. This reaction here is the double displacement. This is the double displacement. We are going to the procedure here. See. Okay, that's just the double displacement here reaction. And I am, it's not, it is. Okay, I'm copy this link here. Sure, this copied. Then, fortunately, I have to stop sharing, and every time I have to be back and forth. It is sharing the video, and I'm writing here. Paste. See. Okay, so take this one here. It has 30. So here it is. Guys, that's the reaction here. Okay, so the third reaction, the third type of the reaction, let me get out of. Okay, so I'm sharing the Microsoft Word again. And the third type of the reaction, we call it have single replacement, displacement, double displacement. Then the third one will be, we'll have our combination. So a combination reaction, when you combine two or more molecules or compounds or just elements combining together to get one single what? One single compound or molecule, correct? So it is third reaction here. Let me just we have third type is combination. Combination is third type of chemical reaction. What happened is in this combination is you are adding two elements or one element with no molecules, two molecules or atoms to obtain, so combination of, well, it's not, so the third type, combination. Two or more molecules combine together. What you are producing one single molecule or compound here. So let's look at one of the reaction here. We'll have a demo of it. I'll show you how to look at the demo there. But we'll see in the video for a few seconds how does it look like. Any question about this? Let me show you what will happen. We'll have our magnesium here, and we'll burn it in the air. What will happen is oxygen is a gas. This is solid. This is gas. We'll get MgO. Okay, MgO is. I did not balance it, but this is, you can put this one too. This one here too. So magnesium what? Magnesium oxide. This is a white solid. Magnesium is grayish, silvery. Oxygen is air, has no color, no smell, it's a gas. So when you combine those together, you get one. So you have one here, one plus one makes one. So combine two items and or more, sometimes more, you get one item out of this. This called here a combination, and it has another name or two other names. This is a combination reaction. Well, this combination reaction has another name. Somebody will know what we call it. We call it synthesis. Synthesis means you are producing a product. Synthesis means, so we call it again, this is called TH here, guys. I'm sorry, but synthesis, or sometimes called again combustion. Now, although sounds very strange, if we have synthesis means that's the correct one here. Magnesium is an element, but if I have, anytime I have a reaction with pure oxygen with organic matter, that's a combustion reaction. So, but this is magnesium, is not organic. So therefore, we'll say this is combination and synthesis. That is one combustion, combination. But if we have a piece of paper, cellulose, sugar, any organic matter with pure oxygen, that's a combustion. We'll look into one examples. Okay, guys. So let me show you how we do the experiment. This is a demo. You will not do it because that's too risky for you to do it. So I will do it for you. So here it is. I will do it the same way that I'll stop sharing here, and then I'll share. No, not really. Let's go back and then get into the reaction here. Go to the procedure. The procedure is magnesium. This is all this stuff here. This is the reaction here. I can take one of this here to show you how does it look like. Copy. I'm copying this one here. Okay, this is synthesis or combination, either or. If I replace magnesium with organic matter, benzene, petroleum, any crude oil, a piece of paper, that's organic. So then we call this combustion. That will come there, another type of reaction. But this time here, we are looking at the combination. We are combining magnesium with oxygen to produce a white precipitate. So let me here, and I'm just stop sharing, going and share it here for you guys. Okay, so paste, and here it is. See, it gives you a lot of UV light. Yeah, that's sort of firework. Yeah, but at least that's the reaction here. You can see, and that's what I'll show you the demo here. I'll do it for you. So, how many now so far? Okay, now we have 3, correct? The number 4 will have something called combustion. And I did really already introduce you to combustion reaction, correct? If you recall, said anytime I have organic matter react with pure oxygen, this is what? This is a combustion reaction. And one of the combustion reaction is here. I will do for you a demo. You don't have to do it. And there's 2 types of demo here. And this is the reaction here, if you look. And there is a complete and there is incomplete type of reaction here. So let me just copy this link and stop sharing. Let me share again. Okay, so pasted. Guys, it is. In your left is cyclohexane, A and E, single bonds. That's cyclohexane, A and E. That's a complete combustion. You don't see any soot. Okay, that's cyclohexene, double bond. See the soot in the top? Can you see the soot? That's incomplete combustion. Whenever you see a reaction with the soot, that's incomplete. So that clean is complete, means complete combustion. The left one is already gone. But this one, you see, you can see it. I mean, I will show you if we have the opportunity, I can show you at the end of the whole thing. You will be surprised to see, you'll see that the complete combustion, you'll see the watch glass clean, but incomplete combustion, that's what you'll see a lot of soot or black charcoal on the watch glass. And that's what the same thing with our chimneys in our houses, correct? The wood is not burned completely. It's not combusted. Wood is organic, lignin, it's organic compound. When you burn it, united with oxygen, it does not go all the way. Are you following me? It does not go all the way. It's incomplete combustion. So you get a lot of, you saw the chimney, lot of black, black charcoal there left over. So that's called number 4, correct? This is number 4, and number 4 is called number 4 called number 4 just bear with me here. I'm just trying to get this one here working. Does not want to go, but I'll go here. Combustion reaction is here in the procedure. This is the combustion reaction. This is does not want to this is a combustion reaction. Cyclohexane is, if you look at cyclohexane, this is cyclohexane C6 H12. You add oxygen to it and you burn it, and they will give you complete combustion, give you CO2 plus H2O. That's the reaction here. So I'm trying to highlight it for you. And so that's the reaction. No, why is not thing here? Anyway, so that's the reaction. The last reaction is decomposition reaction. The last reaction is called decomposition reaction. And if when I go here and look at the so number 4 here, number 4 we said just fourth. Can you see it? Try and make it bigger here. Fourth reaction called what? Combustion. Correct? The combustion is reaction of organic matter with pure oxygen. You have seen yourself the reaction here, and the complete combustion will give you, and if you look at the, I give you 2 other videos. Here they are. So 2 other videos will give you the difference between complete versus non-complete. Those videos here will give you the complete and non-complete. So if I take this one here, copy it, go all the way up. Here it is. So that's the complete C6H12 plus oxygen will give you carbon dioxide. And this is really is a complete, called complete combustion. This one here, complete combustion. As I said, if you have, for some reasons, charcoal there, then it's incomplete reaction. So this is number 1. I mean, number 4. Number 5, we don't have the way I can show you, but at least I can show you a video for that. But we'll not do it here. We'll do it number 5 is called and let me take this one here out. We combine, correct? Can we decompose? Yes. So it's called for decomposition reaction. That's the opposite of combination, decomposition reaction. So if you can combine, you can decompose. If you have calcium carbonate, for example, calcium carbonate, this calcium carbonate, you can decompose it at higher temperature, correct? You can take it out and then you can produce calcium oxide plus CO2 gas. So this is by the way here it is out. This is solid and this one solid, and this is gas. So that's type of reaction. We don't have the whole thing, but I think I can show you type of decomposition here. Maybe I did not put this one here, but I think I put for you the decomposition reaction. That's reactions here. Yeah, we can go and look at one of the decomposition of calcium carbonate. So let me take this one out and stop sharing. We are sharing of and right here, decomposition of calcium carbonate. So let me see where is decomposition. Composition of calcium carbonate. Here it is. So you'll see the bubbles coming out. That's the bubbles coming out, the CO2. The fire will suffocate, the fire will go out. It has to go out because carbon dioxide heavier than air, drive air out, and the flame will go out. Yes, that's what happened. The flame has to go out. If there is gas, okay, guys, let me stop sharing here. The last reaction is the last reaction. You will have the opportunity, because we don't have this calcium carbonate with the students. They might get into some safety issues here. So let me share with you the last type of reaction. We'll do another single replacement, and then we'll do another combination. So what type of reaction we are doing? This is reaction number 5, but that's not the type. That's already, we discussed this one. The first reaction is magnesium with HCl. Okay, so if I put this one here, let me take those two reactions here. We copy them, two reactions. I'm copying them here, and then going all the way up. And this is 5 reactions already done, correct? We are looking for this type of reaction here. Okay, so okay, here it is. Okay, so what will happen is, here it is. Two reactions here you have. So then you have this one here. Let's put it 28. So magnesium with magnesium is grayish, silvery metal, plus HCl, hydrochloric acid. You get magnesium chloride and hydrogen gas. This hydrogen gas, you put the flame on it a little bit with the piece of wood. You'll come to me, I'll show you how to do it, so you can do it yourself. It will start popping. You don't have to be. It's an exothermic reaction. Hydrogen coming out in the oxygen, and then if you the flame, it will what? It will pop out. So this reaction, I will say, just bring me your HCl ready, correct? 2 mL. That's 2 mL, 1 mL is 20, that's 40 drops. And bring it ready to you with the test tube and the holder. And then I will add to it the magnesium, and then I will make a pop. This is just, you know, this reaction is very, very explosive, and you will see that hydrogen will combine itself with oxygen to give you H2O under explosion, of course. So that's this one here. What we call this first reaction here, the top. What we call it? Correct. That's single replacement or displacement. And how about the other one? Well, you can call it combustion, but because you have a pure oxygen, but because it's not hydrogen, it's not organic, inorganic. So we'll say this is a combination or synthesis. Okay, guys, this is combination or synthesis. If that's an organic matter plus oxygen, then you get CO2 plus H2O, and this called here combustion reaction. if you call it combustion reaction, it's not wrong, but in the multiple choices, they will give you multiple choices, but combustion, and you have to be careful. For me and you, okay, combustion, but that's not organic. Hydrogen is not organic. Only if you have organic matter, that will be combustion. So therefore, the answer is those two here. The answer is those two. Unless we have organic matter, then we talk yes. Yes, yes, of course. Everything you have there in the procedure, those tables, it has to be added in your data section. What's that? No, the video is just for your own sake. I will do the two demo, and you can see me. Then just write whatever you see after you are seeing me. Those videos for your own sake, just to utilize the whole thing. How does the whole thing looks like? So I'll stop sharing, and then I will go here to maybe here still sharing the Microsoft Word. And this is reaction here somewhere. If you look at this, the reaction should not take that much of time. So here it is, magnesium. Okay, so this is reaction HCl. Here's the reaction here. I put just for you about put this one here. Copy, and then I'll stop, and then I'll share the edges here. Share it. Here's the reaction of magnesium. It's a very, very vigorous reaction. So you can see, and then how to balance this chemical equation is straightforward. Let me show you here. Okay. Okay, that's another type. Now, hydrogen with oxygen, hydrogen with oxygen give us H2O. Let me just. Let's just show you.
To balance this equation, and on these sides.
That's just the application. We'll come back to that, but at least you. Okay, guys, I'll stop sharing here, and I'll pause the recording here because and I'm sharing here. Listen, guys. Listen, guys. I'm sharing here the balancing chemical equation. We are not done yet, please. So be quiet. We are doing those will come in your final in the lab, your final in the lecture. And if you go for higher chemistry, you have to know how to balance chemical equation. I pick up one of the most difficult ones. So to show you, so I'm copying this one here, copy it, and I will stop sharing. Then I will share the Microsoft Word. Here, guys. So I'm not sure if it's working there on it or not. Yeah, it's working. So I'm pasting the whole thing. This is the reaction, guys. Okay, guys, here it is. This is the reaction here. This is an arrow here. Okay, guys. I said, listen, we are not done yet. Give me a couple minutes. 2 minutes, I will be done. We have, so I'll make a table here. I make what? I'll make a table. So draw, I'll make a table. What we want to draw, not draw, insert a table here. We have 4 items, carbon, hydrogen, oxygen. We have 3 items, correct? Carbon, oxygen, hydrogen. So 3 and 4. So let's insert a table, which is say 4 by 4. We'll make it 4 by 4. 4 and by 4. And then we can delete the whole thing. So guys, whenever you are doing this, you have to do a table. At the beginning, you have to make a table. A table here, you have to look what you have. This is number of atoms here. This type of atoms here. Okay, atoms. What atoms you have? You have carbon, correct? You have hydrogen, you have oxygen. Okay, guys, and then we have, here is left of the reaction, left, that's the left. This is right. The left called what? Reactants. And right called products. And here the status. So carbon at the left, how many? How many carbon at the left? Listen, 10. How many in the right? 2. Perfect, perfect. How many hydrogen in the left? 22. How many in the other side, in the right side? Hydrogen? 2. You said carbon at the side, the other one is not 2, it's 1. Why somebody said 2? Oxygen, how many in the left side? 2. How many in the right side? 3. Here we have 2, correct? Just highlight this one here. 2. And here is 1. This is 3. When it comes to balancing chemical equation, and you have even, odd, even, especially with the oxygen, you have here 3, correct? So you have a 3, so your intuition will tell you this is an odd number, correct? And this is, oops, you might have to go through a fraction. So here it is, that's even number. So what the best way to do it, you can start anyway. So because the oxygen, my experience is telling me, my intuition telling me, I'll keep oxygen by the end. I come and then do first the carbon. So what I should do in front of the carbon here? 10. Why does 10 carbon? So 10 and 10. So this one is now, I'll strike this one out. I strike this one out and put this one here. I have now 10. Then the 22, I have to put here in front what? 11, correct. Then I have this one here is, I'll strike this one here out. Then it will be 22. This is, I'll say, the status now, this is balanced. This is balanced. This is not. Okay, so my intuition tell me I have here, the oxygen is to the left, but in the right, how many? 10 multiplied by 2, that's 20, correct? And here is 22. So how much is that totally? So this one here, let's take it out. Strike it. I have now a new value, which is, how much is it? 31? 31 or 32? 22 plus 11. How much is it, guys? That's 20. 20 and 11. 21, 31, correct? Correct me if I'm wrong. So this is the hydrogen, the other side is 22, correct? The carbon is 10. So 20 plus 11. 20 plus 11, 31. Just correct me if I'm wrong, guys. Correct me. So this is 31. I'll take the strike out. So in order to get into throughout this, I have to go, because I have odd and even situation. I have odd and even situation. So I have to get out the fraction. I put at the top here, 31, correct? And because the oxygen is here, get another number here, maybe no, yellow. I put at the bottom here, the 2. I put this fraction here, 2, correct? So the 2 will cancel out the 2 here. Okay, guys? But nature does not like this. Nature does not like nature does not like the fraction. So I have to take this one here and multiply the whole thing by what? To get rid of the 2 here. So multiply the whole thing here by 2. So 2 multiply by the whole thing here. Okay. 2 is here. And multiply here. So then it will be the 2. This is the whole thing multiply. So how many of this here? Put this one here, all of it here as is. Copy. The 2 will come, right? 2 multiplied by, and the whole thing here is this one out, and the whole thing in red. This is 2. 2 multiplied 31 over 2. 2 cancels out. That will be 31, correct? 2 multiplied by 10. That is 20, correct? And 2 multiplied by this is 22. Now let's check the whole thing now. This one here, the carbon is now, strike this one here will be how much? Now will be carbon is 20 in the left, correct? And this one out. How about in the right? Did we put the 10? Here this has to be 20. Not even check it out. Okay. Oh, bottom, yeah. So 20, then here it is. Take it this one out. And this is 20, correct? Okay, so this is good. It's balanced here. Balanced. Carbon is balanced, okay? How about hydrogen? Hydrogen is, how much is it here? How many? Now you have hydrogen 22 multiplied by 2, 44. Yes, 44. So hydrogen is 44. How about the other side? 22 multiplied by 2 is, strike this one out. How much is it? 44, correct? That's balance. Now, how about the other one? We have 31 oxygen multiplied by 2. This is 62. So this one here now, for oxygen here, let's take it up, 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 up. Up. So this one here is 62 now. 62. Okay. And this is not balanced. Okay. So now here you have how many? You have 22 plus 22 plus 40 plus 20 plus 40. So 20 multiplied by 2, that's 40. Plus and plus 22. How much is it? 62. Now it is balanced. This is the final equation here at all. This is final one. Okay, guys, I'll see you then next week.